Hi, this lesson is on Moore power rule and some applications. So our learning goals are to consolidate learning of the power rule, to find the derivative, and to find the slope of the tangent at a specific point. We're learning to solve problems as well, involving using the power rule to find the instantaneous rate of change. So our first question, state the derivative of each function. So they're giving us the function f at x equals 8x to the power of 12 minus 14x squared plus 8x minus 10. So using the power rule and sum for a power rule, we can just find f prime at x. So it's going to be 12 times 8, which is 96, x to the 11th, reduce the exponent by 1. And then minus 2 times 14 is 28, x to the 2 minus 1, which is to the power of 1, plus 1 times 8 is 8, x to the 0, and then minus 0, which we don't need to show. So there's our derivative, f prime at x equals 96, x to the 11th minus 28x plus 8. Our next one, b, derivative of the function, so y equals x cubed over 12. So in this case, I think I might want to first rewrite it as 1/12 x cubed. Not necessary, but might be easier to write it that way or think of it that way. And now we're ready to take the derivative. So y prime is going to be 3 times a 12th, which is 3/12 or 1/4 x squared. And then the third one here, we definitely would want to rewrite in exponential form before we take the derivative. So I'm just going to rewrite y. Remember, it's really important that if we're just rewriting y in a different way, that we still have y on the left side. And then I'm going to rewrite this using our exponent rules. Just reiterating here that the fourth root of x is the same as x to the 1/4, but then we want to write it as a power function, so we want to write it as 3x to the negative 1/4. So that's just rewriting y, and now we want to find y prime using the power rule. So that's going to be negative 3/4 x to the negative 5/4. And again, that would be because we're taking the exponent of negative 1/4 and subtracting 1, which is the same as subtracting 4/4. But then we don't want to have our final answer containing a negative exponent. We want it written in radical form like the question was given. So we would write it as negative 3, y prime equals negative 3 over 4, and then the fourth root of x to the 5th is how you would write that. Remembering again that we learned in grade 11 that x to the m over n is the same as the nth root of x to the m. Okay? All right. Next question, find the equation of the tangent line. So our answer is going to be in the form y equals mx plus b because we want the equation of the tangent line. To the curve y equals 2 root x at the point 9, 6. Okay, so here's our function, y equals 2 root x. And we want to find the equation of the tangent line at this specific point on the curve. So first we want to find the slope of the tangent at that point on the curve. So first I'm going to rewrite y so it's in exponential form. So it'll be 2x to the 1/2. And then I'm going to find the derivative. So y prime, 1/2 times 2 is 1, x to the negative 1/2. Or I can write that more nicely as 1 over the square root of x. Then we want to find the slope of the tangent at 9. So y prime at 9 is 1 over the square root of 9, which is 1/3. Okay, so now we know the slope of the tangent is equal to 1/3 at the point 9, 6. And now we can find the equation of the tangent line using y equals mx plus b, where y is 6, m is 1/3, x is 9. So that's going to give me 6 is 3 plus b, subtract 3 on both sides, and we get b, or the y-intercept, is 3. And now we can conclude that therefore the equation of the tangent line to the curve y equals 2 root x at the point 9, 6 is y equals 1/3 x plus 3. And I just want to show you that on a graph. We can use the graphing program Desmos. Desmos graphing calculator here. And I can type in y equals 2 square root of x, and it will show me the graph there. And then I can plot that point 9, 6. So let's move over here. 9, 6 is right there. Keep that in mind. And then my tangent line is y equals 1/3 x minus 3. Sorry, plus 3. My bad short-term memory here. And then there's our tangent line. So you can see if you look here at the point 9, 6, which is right here on my screen, you can see that that is the tangent line there. It looks perfect. Touches it at the one spot at the point 9, 6, and best resembles the slope of the curve. There's my tangent line. And Desmos is a graphing calculator you could use when doing questions like that to make sure that your answer makes sense. So at what point on the parabola y equals 3x squared is the slope of the tangent line equal to 24? So, all right, so first of all, we've got our function y equals 3x squared. We want to know where is the slope of the tangent equal to 24. So first we're going to find an expression for the slope of the tangent by finding y prime. So y prime equals 6x, that represents the slope of the tangent anywhere. Remember, this means the slope of the tangent y prime. And we want to know where is the slope of the tangent, y prime in other words, equal to 24. So I can replace y prime with 24. And then if I divide here, I should get the x value where the slope of the tangent is equal to 24. And I get 4 for my x value. I also want the y value that goes with x being 4, which I can find using my defining equation here. So that's going to be 48. So that means, therefore, at the point 4, 48 the slope of the tangent to the curve y equals 3x squared is 24. So the slope of the tangent is 24 at the point 448 on the graph of y equals 3x squared. All right, our next question. At what point on the curve y equals x to the fourth minus 25x plus 2 is the tangent line parallel to the line 7x minus y minus 2 equals 0? So we want the tangent line to be parallel to this line. So back to grade 9, when we were talking about parallel and lines, parallel means same slope as. So where does the tangent line have the same slope as this line here? Okay. So, well, one thing we'll want to know is what's the slope of this line here? And we know that if we have it in the form y equals mx plus b, we'll know the slope. It will be the m in y equals mx plus b. So therefore, the slope of this line here is 7, okay? So we just put it into the form y equals mx plus b, and we know the slope of this line is 7. So then we can reframe the question, at what point on this curve is the slope of the tangent equal to 7? Because at that point, it's going to be parallel to this line. It's going to have the same slope. So it's very similar to the one we just did now, question number 3. So we want to find, we'll take our curve y, and we're going to find y prime, which is an expression for the slope of the tangent anywhere. So the slope of the tangent at any point x can be found using the formula y prime, or the slope of the tangent, is equal to 4x cubed minus 25. It's just using the power rule. And we know the slope of the tangent, we want it to be 7. And now we want to solve for x. So we can add 25 to both sides. 25 and 7 is 32. Divide both sides by 4. And then we want to get x by itself, so we can cube root both sides. So that gives us that x is 2. Okay, so at what point on the curve, not just the x value, at what point on that curve is the tangent line parallel? So we can take our x equals 2 and find the corresponding y value to our curve. So it's going to be 2 to the 4th minus 25 times 2 plus 2. Which is going to give us negative 32. So that, what does that say then? That says at the point, so therefore at the point 2, negative 32, the slope of the tangent to the curve y equals x to the 4th minus 25x plus 2 is parallel to the line 7x minus y minus 2 equals 0. Okay, and question 5, a word problem here. the population of a bacteria culture is given by the function P at t, so population at time t is equal to 500 plus 200 times t plus 12 times t squared, where time is measured in hours. So what is the population at 4 hours? So notice this question doesn't ask anything about rate, average, or instantaneous. It just wants the population. So that's just asking you for P at 4, the population at 4 hours. So we can just use function notation. And find out the population. So we can type in 500 plus 200 times 4 plus 12 times 16. We get 1,492. So therefore, the population of bacteria at 4 hours is 1,492 bacteria. Now we're talking rate. So what, in part B, what is the average rate of population growth over the first 4 hours? So we want to find the average rate. So average rate is going to be, so over the first 4 hours means I want the population at 4 hours minus the population at 0 hours divided by 4 minus 0. And we know the population at 4 hours because we were asked to find it in step 1. There's 1,492. P at 0, we're going to substitute 0 into our defining equation up here. So that's going to give us 500, because otherwise we're multiplying by 0 there. So minus 500 over 4. So 1,492 minus 500 is 992. Divided by 4 is 248, and every rate has to have units. So that's going to be bacteria on the top. So population of bacteria are the units for the numerator, and the denominator is hours. So bacteria per hour. Okay, rates always have units that are something per something. So then we need a nice therefore statement here. So therefore, the average rate of population growth over the first 4 hours is 248 bacteria per hour. And then what is the growth rate at t equals 5 hours? Okay, so I'm going to start off just recopying our function here. So population of bacteria at time t is 500 plus 200t plus 12t squared. Now I'm going to find p prime at t. So the rate of change, the instantaneous rate of change at time t is going to be the derivative. So the derivative of 500 is 0. Derivative of 200t is just 200 plus 24t. So that's at any time t, and now we want to find it specifically at t equals 5 hours. So we're going to substitute in, ending up getting us that p prime at 5 is 320 bacteria per hour. And then a nice concluding statement then. So what is the growth rate at t equals 5 hours? So therefore, the growth rate at t equals 5 hours is 320 bacteria per hour. All right, so that is our lesson on power rule and solving problems with power rule. Okay, stop recording here. There we go. Sorry guys, trying to figure out how to stop recording here.